Welcome back. In this section, we'll be looking at polynomials. Recall from previous classes that if we were talking about a polynomial with one variable, then it would be something where we had a bunch of terms involving that variable, where the powers on our variable are all just non-negative integers. So in other words, our powers are 0 or 1 or 2 or 3 or 4 or other larger numbers, but no fractional powers and also no negative powers. If our polynomial is written in standard form, then we've written it going from highest power down to lowest power, and that's what I've sort of got written here. You'll see in front of the powers of x's, I have these an's and an minus 1's and all the rest of those. Those are just representing the different numbers that might be in front of the x's. Those are our coefficients. There's no restrictions on what those can be. They can be any number we'd like. They don't have to be integers. They don't have to be positive or negative numbers in particular. They could be whatever, any kind of number, as long as it's a real number. There's a couple of special terms in this polynomial. The first is the term that has the highest power of x. This would be the term that we call the leading term for our polynomial. And it's the leading term whether or not we've written it in standard form. So even if this was the last term that we saw, if it was the term that has the highest power of x, then we call it the leading term. And we'd call its coefficient that leading coefficient. The other important term that we have would be the term that doesn't have any x's involved. That would be our constant term. We're going to see later on that when we start to think about these as functions that can be graphed, that the leading term and the constant term will tell us stuff about what the graph would look like. Just for right now, we should just know what those words are, the leading term and the constant term. The other thing that we have for our polynomial is the degree, and the degree of our polynomial is the highest power of x that we have. So when we identify what our leading term is, we also are identifying what our degree is. So if you had a polynomial where, for example, here the highest power of x is 3, then this would be a degree 3 polynomial. For that polynomial that I've underlined, 3x cubed would be the leading term, 3 would be the leading coefficient, and positive 1 would be the constant term. So again, sort of just a reminder here that when we're talking about powers of x, if it's a polynomial, those powers of x can only be non-negative integers, so integers that are 0 or larger. So if you see any sort of a root, like a square root, then you don't have a polynomial because, as we remember from the previous section, a root is a fractional power. So square root of x, that's not a polynomial because that would be x to the half. If you had x's in the denominator, that means you've got some sort of negative power. So if you had 1 over x, that's really x to the negative 1. So again, that wouldn't be a polynomial because we have a negative power. So for this little example that we have here, we've got a polynomial, and currently it's not written in standard form. It's not written from highest power to lowest, which is probably a good idea for us to do before we answer the questions about the degree, the leading term, and the constant term. So if I were to rewrite this, I would start with my highest power of x, so 10x to the 7, and then the next highest power is the cubed power, then the squared power, then x, and then 4. So now, if I'm taking a look at this, I can see that the degree for this polynomial is my highest power, which is 7. And I know that because my leading term is 10x to the 7. Just as a little side note here, for the leading term, that's both parts, the x as well as the coefficient. So just x to the 7 is not the leading term. The leading term is 10x to the 7. If we wanted to know what's the leading coefficient, that would be the 10. And for our constant term, that would be 4. Now, when it comes time to do work with polynomials, to add them or subtract them or multiply them, we're going to leave dividing polynomials for a later chapter. We've seen all of those things before in previous classes. For adding and subtracting polynomials, we just need to add or subtract the terms that have the same power of x, and when we do that, we're really just adding the coefficients. For multiplying two polynomials together, we just need to remember that every term from the first polynomial will multiply by every term of the second polynomial. So let's just do a few examples here. I've got two polynomials, two small little ones, and I want to multiply them together, and I'm going to expand and simplify. So I remember from previous work with math that I'm going to have to take every term from the first polynomial and multiply it by every term in the second polynomial. When we're doing that, we're going to multiply the coefficients together, and we're also going to multiply our x's together. When we multiply the x's, of course, we're going to be figuring out our new power by adding the powers together. So let's start off with beginning. We're going to start off with 4x times 3x. So when I do that multiplication, I'll have 4x times 3x. 4 times 3 is 12. And x to the 1 times x to the 1 is x to the 1 plus 1, or x squared. I'm just using my exponent rules that I have, and that was one of them that we saw at the very beginning of the course. And I'll continue on. 4x times 7, that would be 4 times 7, which is 28x. And now I'll do negative 3 times everybody. Negative 3 times 3x would be minus 9x. And negative 3 times 7 would be negative 21. The only thing left for me to do now is just to combine together those two terms that involve x to the power of 1. So the 12x squared term will stay as it is. For the x term, I'll have 28x minus 9x, and 28 minus 9 is 19. And there we go, so 19x. And the constant term 21 will stay as it is. Okay, so the next one up, this one involves a little bit of subtraction. You can see that we've got one polynomial subtracting another one. I'll deal with the subtraction later on, because I notice for the first one, I have this 8x squared plus 2 squared. The first thing, just to remind ourselves, and this is again one of the other things that are true, or rather not true about math, is that if you have two things that are being added and the whole thing is being squared, that is not the same thing as just squaring the first term and squaring the second. So when we see that 8x squared plus 2 squared, if we're thinking, oh, I'll just square that 8x squared and square the 2 and then I'll be finished, that, of course, is not right. And the reason it's not right is because 8x squared plus 2 whole thing squared is really 8x squared plus 2 times another 8x squared plus 2. So we're going to have to do, again, a bunch of multiplications. The 8x squared is going to need to multiply by everybody in the second bracket, and the 2 is going to need to multiply by everybody in the second bracket. So again, we're going to have 4 little products for us to do. Okay, I'm just going to write out the rest of what I've got here. So the 3x squared minus 2x plus 4. And like I said, I'm going to deal with the subtraction later, because with order of operations, we know multiplication comes first before we deal with addition and subtraction. So I'll start off. 8x squared times 8x squared. 8 times 8 is 64, and x squared times x squared is x to the 2 plus 2, which is 4. I'll have 8x squared times 2, so 16x squared. I'll have 2 times 8x squared, so that's another 16x squared. And I'll have 2 times 2, which is 4. Now, one thing I'm going to do here, just to be a little bit cautious, is I'm going to now carry my negative through that bracket, through that second bracket, because I know that if I don't, the chances are good that I'll remember to subtract the positive 3x squared, but I may not remember that the other two terms also need to be subtracted as well. So this makes it a little easier if I just go ahead and carry that negative through the bracket. I've got a minus 3x squared. Minus negative 2x is plus 2x. Minus positive 4 is negative 4. And now I can go right ahead and finish my simplifying by combining the terms that have the same powers of x. So I've got 64x cubed for my powers of 4. There are no powers of 3 here, so I don't have any x cubes. I do have 3 terms that involve x squareds. I have 16x squared, another 16x squared, and then minus 3x squared, which gives me 29x squareds in total. For the x's, I can see only one term involving x, that's positive 2x. And for constant terms, I have a positive 4 and a negative 4, and so they just cancel each other out, and we are finished. So as simplified as we can get, 64x to the 4 plus 29x squared plus 2x. Now, if we have more than 2 things multiplied together, then we just need to do it in stages. So I won't be able to do all 3 brackets multiplied by each other in one go. My plan is going to be I'm going to take everybody from the first bracket and multiply it by everybody in the second bracket first. And I'll leave that little x minus 7 by itself, so that I'll wind up having now just 2 brackets. One bracket that I'll get from the 2x minus 1 times the 3x plus 1, and then I'll still have the x minus 7 left over. Then I'll multiply those 2 brackets together, and then I'll be finished. So I'm going to start off with leaving, again, as I said, leaving that x minus 7 alone, and just dealing with the 2x minus 1 times the 3x plus 1. 2x times 3x is 6x squared. 2x times 1 is 2x. Negative 1 times 3x is negative 3x. And negative 1 times positive 1 is negative 1. Now, one thing that would be a useful thing to do here, and this is what I'm going to do, is to, before I continue multiplying, simplify that bracket, because I have a 2x and a 3x that can be combined together. As it stands now, I've got 4 things in that first bracket, and if I simplify, I'll only have 3 things, so that'll give me less multiplying to do later on. So I'll do that. 6x squared minus x minus 1, that's what I now have, times x minus 7. And now the only thing left for me to do is to finish off my multiplication. And I do that again by taking everybody from the first bracket and multiplying it by everybody in the second bracket. So I'll begin by taking 6x squared and multiplying it by x. That gives me 6x cubed. 6x squared times negative 7 is negative 42x squared. And then I'll do the same thing with the next term, negative x. Negative x times x is negative x squared. Negative x times negative 7 is 7x. And then finally I'll finish it off with negative 1 times everybody. Negative 1 times x is negative x. And then negative 1 times negative 7 is positive 7. And then last thing for me to do is just to combine the terms with the same powers of x. So 6x cubed is my cube term. For x squared, I have minus 42x squared minus 1 more, so minus 43x squared. For the x's, I've got 7x minus an x, which is 6x. And then for the constant term, I've only got that positive 7.